Okay, well, we're getting pretty good with the naming and finding the formulas for ionic compounds. Let's do some now with a little bit of wrinkles to them. What happens if we were going to do ionic compounds that contain transition metals? So when we get ready, let's take for an example, say tin with oxygen. So we're going to do it like we do normally. We're going to go ahead and make ourselves a scale. And we're going to put tin on the left-hand side. Since it's the metal, it's going to be a cation. And right away we notice when we're looking at our oxidation sheet that tin has two possibilities. It could be tin that makes a +2 ion, a +2 cation, or it could be tin that makes a +4 cation. So I'm going to do them two kind of right next to each other. In a problem, you'd never have to do them both at the same time. You'd just do one or the other. So if it was tin +2 with oxygen, oxygen's always going to make a -2 anion. So we can see that on the left-hand side, our scale is balanced. This molecule is neutral, and so I could just go ahead and write the formula for it. This would be SN, 1 atom, with oxygen, 1 atom. Clean it up a little bit, and we'd have SNO, tin oxide. But on the right-hand side, we can see that these aren't balanced, that we'd need another oxygen to balance it out. And so our formula for this one would come out SN, 1 atom, oxygen, 2 atoms. When we clean that up, we would get SNO2. And those certainly are not the same thing. SNO and SNO2 are not the same thing. Remember again, the difference between H2O and H2O2 is just 1 atom of oxygen difference, but one will bleach your hair white and the other would just make your hair wet. So there has to be a way for chemists to tell each other that which one of these are you using. Are you using the +2 cation or are you using the +4 cation? So the way that we do this in the naming is that we would go ahead and write the name for this to be tin, Roman numeral 2, oxide. And the Roman numeral relates to the charge on the cation. Notice that it doesn't have anything to do with the number of atoms that are in the formula, because in the formula, tin has only 1 atom of oxygen and 1 atom of tin and 1 atom of oxygen. So the Roman numeral 2 is only related to the charge of the cation. So following that pattern, this side would be tin, Roman numeral 4, oxide. Once again with the Roman numeral telling us that we used the +4 version of the cation of tin. As I said, we'd never have to do them both simultaneously. We'd just get one or the other. So let's pretend we got a problem of Cu with O. And we have to go ahead and write out its name. So that's its formula, CuO. So we would do the same thing we've always done. We make ourselves this little scale. On the left-hand side would go copper, and right away we would realize we don't know what charge to make for copper. Oxygen is a -2. But the formula tells us that we had 1 atom of copper and 1 atom of oxygen. So these are all that's on my scale. So how am I going to get that to balance? It must be copper at the +2 choice. So when I go ahead and write out my name, this becomes copper, Roman numeral 2, oxide. Important to notice that the Roman numeral 2 doesn't refer to how many atoms there are in copper in the formula, but instead to the charge on the cation. Also notice that the Roman numeral 2 doesn't appear anywhere in the formula, but just appears in the name. Going the other way, giving the name mercury, Roman numeral 2, oxide. And now our charge would be to make the formula. Same idea, we'll go ahead and draw our scale. cation on the left, we want to put in mercury, and the Roman numeral 2 tells us that the mercury we must have been using was the +2 version. And you need this because when you look on your oxidation sheet again, you'll notice that there's multiple choices for mercury. Mercury could be a +1 or a +2, and in this case we must have used the +2 version. The oxygen is always a -2. So now we look at that, we say, hey, we're balanced, so that's fine. Time to go ahead and write our formula. There's mercury, 1 atom, oxygen, 1 atom. Clean it up a little bit, HGO. Once again, notice that there are no Roman numerals in the formula, just Roman numerals in the name, and that the Roman numeral in the name relates to the charge on the ion, not the number of atoms that are in the formula. Let's try, say, manganese, Roman numeral 4 oxide. Once again, we get ready to make our scales. And as soon as we do, we try to put manganese on this side, and we realize that manganese has lots of choices, a +2, a +4, +7, I think. I'd have to look at my little oxidation sheet. Lots of different choices for manganese. But oxygen's always the same. It's always a -2. And the name here tells us that if it's the +4 version, that's what we must have here as our charge on this cation, the +4 version. Our scale isn't balanced. In order to balance it, we're going to go ahead and put another oxygen on it. Now we're balanced, and it's time to write the formula. Manganese, 1 atom. Oxygen, 2 atoms. Clean it up a little bit, MnO2. MnO2 is the formula for the compound that's called manganese 4 oxide. No Roman numerals in the formula, only in the name. Now they give us a formula, Fe2O3, and they'd like to know its name. Let me go ahead and draw our scales. We draw our iron on the left-hand side. The formula tells us there must have been 2 irons on the left, but when we look on our oxidation sheet, we can't tell what charge they are. So that tells us, hey, we're going to have to go ahead and use Roman numerals in this. Anytime you can't tell the oxidation number, you'll have to use the Roman numerals. There were 3 atoms of oxygen, as you can see, and so now I need to balance this up. The formula tells me all that I can have on the left-hand side is 2 of the iron atoms, so it must be that each of these is +3 in order to balance that out. So now that it comes time for the name, I write in iron, Roman numeral 1, 2, 3, oxide. You have to get used to the fact that you use the Roman numerals anytime the cation has more than one choice. This could have been a +3 or a +2, so that tells me use the +3. Don't get all excited and carried away with yourself. If we're doing NaCl, we're going to break it into its 2 parts. Na always makes a +1. Cl always makes a -1. We put together the formula is NaCl. And now we look for the name. The name is sodium chloride. No need for a Roman numeral because there's only one choice for this, so there is no Roman numeral in here.